Imagine you're settling into your seat on a perfectly routine flight. The seatbelt sign dings off, people are relaxing, walking the aisles, and then, without a single second of warning, the floor literally drops out from under you. On August 4th, 2026, that nightmare became a reality. Today, in this explainer, we're opening the dossier on Air India Flight AI2379, a commercial airliner that plummeted midair, sparking international headlines and a fierce debate over what really happens when we unbuckle our seatbelts at 36,000 feet.
To really understand the stakes here, we have to look past the data for a second and focus on the 134 passengers and 8 crew members who were actually on board. A completely standard morning commute over the Bay of Bengal transformed in an instant. One passenger described the survival of the event as a literal rebirth, especially after having to watch his own 2-year-old daughter get violently thrown into the aisle.
So, we're going to reconstruct this chaos piece by piece. We'll start with the terror over the bay, decode the actual flight data, break down the science of clear air turbulence, investigate the verified facts versus the rumors, and finally, look at the ultimate safety verdict.
Part 1. Terror over the Bay. August 4th, 2026. Phuket to Delhi. So, Flight AI2379, which was an Airbus A320 registered as VTEXO, was cruising smoothly, absolutely no red flags. Because there was no warning whatsoever, the seatbelt signs were off. And when the aircraft suddenly dropped, unbuckled passengers, the crew, loose luggage, everything was violently thrown upward, literally crashing into the ceiling. The aftermath was completely chaotic. Overhead bin flaps were hanging open, debris was just scattered everywhere, and there were visible physical cracks on the cabin ceiling. By the time the dust settled, 17 people were injured. That's 13 passengers and 4 cabin crew, with 1 crew member actually sustaining severe injuries.
Part 2. Decoding the flight data. Let's track VTEXO. The morning really did begin without incident. They took off from Phuket at 8:27 a.m. Indian Standard Time. By 9:18 a.m., they had climbed to a comfortable cruising altitude of 36,000 feet, and they just stayed there, perfectly stable for nearly 50 minutes. But then, at exactly 10:09 a.m., just outside Indian airspace, the turbulence struck. It's incredibly fortunate that despite the absolute chaos in the cabin, the pilots maintained control of the aircraft. They actually managed to bring the plane down for a safe landing in Delhi at 11:07 a.m., which, surprisingly, was 43 minutes ahead of schedule. Now, right after this happened, the internet just exploded. Panic and speculation took over forums like Reddit, with people claiming the plane suffered this apocalyptic 5,000-foot freefall. But human perception inside a plunging aircraft is highly deceptive. When we look at the objective ADS-B data from Flight Radar 24, it paints a very different, but completely verified picture. The plane actually experienced a sudden altitude drop of somewhere between 300 to 425 feet, and this all happened within a tight 94-second window. If we isolate the telemetry even further, we find a truly terrifying 32-second window. At 10:09 and 22 seconds, the plane was perfectly level, 36,025 feet. But just 32 seconds later, it was down to 35,900 feet. Now, a 125-foot drop might not sound catastrophic when you're literally miles up in the sky, right? But losing that much altitude in just half a minute generates immense, violent G-forces inside the cabin. So, the multi-million-dollar question is this. What unseen force is actually capable of swatting a 400-ton commercial airliner out of the sky like a fly? And why did the pilots, who are sitting behind state-of-the-art weather radar, fail to give the cabin any warning at all?
Part 3. The science of clear air. Decoding the atmosphere. The culprit here is something called clear air turbulence, or CAT. As the name suggests, this happens in completely cloudless regions. Because there are no water droplets or ice crystals for an aircraft's weather radar to bounce signals off of, CAT is entirely invisible. The pilots literally couldn't see it coming. And this phenomenon isn't isolated to this one Air India flight. We've seen similar massive turbulence incidents globally, like the fatal Singapore Airlines drop over Myanmar or those sudden Hawaiian Airlines events. They all prove just how fast clear blue skies can turn deadly.
In this specific case, the A320 was navigating a highly volatile corridor over the Odisha coast, which is basically an area bathing in unseen atmospheric violence during the August monsoons. The route crossed the monsoon trough, a superactive air mass right over the Bay of Bengal. You've got this warm, wet air sitting over a 28 to 29 degrees Celsius sea, creating deep convection. This fuels cumulonimbus storm towers that can literally build up to 16 kilometers high. When the plane hit the coastal transition zone right above Odisha, where the ocean air meets the hot land mass, it slammed into the intense, invisible updrafts and downdrafts associated with these massive weather systems.
Part 4. Verified facts and rumors, investigating the aftermath. Once the plane was on the ground, a totally different kind of storm started brewing. Conflicting narratives popped up almost immediately. On one hand, you had passengers like Shilpi Jain taking to social media alleging that the cabin crew actually suppressed people from recording videos to protect the airline and claiming that medical response in Delhi was severely delayed. On the other hand, Air India went on the record stating that standard safety protocols were fully executed. They insisted their ground assistance and medical teams immediately assessed and supported the injured right at the airport before moving them to hospitals.
To cut through the online noise and find the actual truth, India's aviation regulator, the DGCA, launched a comprehensive internal probe. They immediately secured both the flight data recorder and the cockpit voice recorder, which are basically the black boxes that will definitively prove the aircraft's movements and the crew's actions. It's also being taken incredibly seriously at the government level. Civil Aviation Minister Rama Mohan Naidu personally met with the injured passengers to ensure they were getting assistance.
Part 5. The final safety verdict. The physics of inertia. At the end of the day, behind all the radar data and complex meteorology lies the incredibly unforgiving physics of inertia. When a 400-ton aircraft hits a severe atmospheric downdraft, its altitude drops instantly. But any unrestrained passengers and loose objects, they just continue moving in their original, stable path. The plane essentially falls away from the people inside it. That means anyone unbuckled is going to meet the ceiling with incredible, bone-breaking force.
Look, modern commercial airliners are engineered to withstand immense structural stress from turbulence. The airframe is going to survive just fine, but the fragile human bodies inside, they are entirely vulnerable to the hard plastic and metal surfaces of the cabin interior. As aviation experts point out, keeping a seatbelt fastened whenever you're seated remains one of the single most effective ways to prevent serious injury. It's really that simple. Air India Flight 2379 proved in terrifying fashion that a smooth cruise is never, ever a guarantee. Our skies are hiding invisible atmospheric traps capable of dropping a massive airliner in seconds. So the next time you settle in for a long flight and hear that seatbelt chime turn off, will you ever leave it unbuckled again?